Hello, chemistry scholars. I know you're excited for your celebration of knowledge that's coming up. So let's do a little review so that you can really party. You gotta get ready for the party if you want to do well. So we've got our conversion diagram here that helps us to convert between all these different units. All right, and remember our steps to address one of these typical conversion problems. This first thing we want to do is we want to annotate, and you want to figure out what do you start and end with. All right, once you know that, you want to plan it out. So you want to plan out your conversions, where you're going to start, where you're going to end, how you're going to get there. All right, then you want to use conversion factors. And remember, the unit on the bottom is to cancel. Unit on the top is what you're going to. All right, and then you just keep chugging along. So I'm going to do one as an example, and then that's pretty much it, because really this whole unit is just conversions. That's all it is. It's just a combination of unit 5 and 4. That doesn't mean it's easy, but it's that's all it is. Okay, so we've got a reaction here. 2C2H6 plus 7O2 goes to 4CO2 plus 6H2O. So it's already balanced for us. And it's asking how many moles of carbon dioxide are produced when 12 grams of ethane reacts with excess oxygen. Okay, so first thing I'm going to do is annotate. I know carbon dioxide is CO2. Ethane has to be this one because the rest of them I know. That's oxygen, that's carbon dioxide, that's water. So that would be C2H6, and then oxygen's O2. It says excess oxygen, which means I have more than enough, so it really doesn't matter how much I have, so I'm just going to get rid of that. And then if I look back at my steps, I got to figure out what do you start with and what do you end with. So I know it's asking, right? Look for the question words, asking how many moles of carbon dioxide, and it's giving me 12 grams of ethane. So I know I'm starting with grams, and I know grams is a mass, right? It says grams right here. So now I know that means I'm starting with mass A, and it's asking for moles of carbon dioxide. Now let's figure out my A and B here. So A is the chemical you start with, which means ethane is A. I'm starting with it, and I'm going to carbon dioxide. Well, carbon dioxide is different than ethane, so I'm going to put B. Okay, and I just want to annotate. I want to say CO2 is B because it is a different chemical. All right, so that's my little annotation right there. See, I typed it out so you can actually read it. Here, I'll change it to blue to match the rest of them. All right. So I know I'm going to moles of B. So to continue planning out, I'm going to put that at the end. And then you won't have this conversion diagram, so make sure you memorize it or just understand that you always have to go through moles. And you can, the first thing you can do if you want is you can just write it on the test, if that helps you, but you won't be able to bring in any notes of your own. Okay, but anyway, where was I? We're going mass A to mole B. So that means I'm starting right here at mass A, I'm ending at mole B. So to get there, I have to go through mole A. So mass A to mole A to mole B. All right, so my mass here is 12 grams of C2H6. Got to do my conversion. I know I've got to have grams C2H6 on the bottom. And on the top, I'm looking for moles. Hold on, though. What was it? Moles A is what I'm looking for right now. I know A is ethane because I annotated C2H6. Now, what do I use to convert grams and moles? Well, if you look at your diagram, you know it's molar mass. Easy way to remember it is that you have mass and moles. So it's mole mass, molar mass. So you use your periodic table. So you know that carbon has a mass of 12, and there are 2 of them. Plus the hydrogen has a mass of 1, and there are 6 of them. So you have 24 plus 6 gives you 30 grams per mole. So that's 1 mole for every 30 grams. Grams cancels out. You can do your math. Gives us, what, 2/6? You can divide both by 6. Gives you, oh no, it gives you 2/5. So 0.4 moles C2H6. Right, because we can reduce both by 6. That would give us 2 here and 5 here, and then 2/5 is 0.4 moles. So now we can do our second step. Just change to a different color because it's our second step here. Moles of C2H6. We want to cancel out moles of C2H6, and we want to go to mole B. So I know it's going to be mole, but I already forgot what B was. Oh, good thing I annotated. B is CO2 right there. It's a different chemical, that's why it's B. So moles CO2. And then you know that you get the mole ratio because you're going in between 2 different chemicals. So you get that from the chemical equation. So there are 4 CO2s for every 2 ethanes. So wrong one. That should be 4. This is 2. So that reduces to 2, so you get 0.8 moles of CO2. All right, so we would need 0.8 moles of carbon dioxide are produced. So this is a theoretical yield, although yield is typically in grams, because it's predicting how much should be produced. Right? Now, if you try to capture that, you may actually end up with more or less, typically less, because you'll have leaks and stuff. More doesn't really make any sense. Okay, but this would be a theoretical value. So just kind of connecting it to the lab. Theoretical, and I bet you I spelled that wrong. Actual would be if you actually did the experiment. Alright, I hope this review was helpful. Remember, office hours are on Thursday. Make sure to come before the exam so you don't have to come after to do retakes.